In symmetric multiprocessing, all the processors have essentially identical and perform identical functions. Identical functions. So all processor will do the same task. So we do not have any master slave concept over here. All processor can run simultaneously without causing deterioration in the performance. So all of these processor can work simultaneously without deterioration in the performance. We have to ensure that data reaches the appropriate processor so that no processor sit idle. So we must ensure that every processor should be engaged in performing the task. There is another kind of parallel systems are called the blade servers. Blade servers. What are these blades are? Blades are literally servers on card. Means on a card you can have everything is integrated. What is that? Containing the processor, memory, integrated network controllers. All those are being integrated on a card itself. So it says the blades. So blade means these are servers, but on a card. So many components are removed to save space, minimize the power consumption and other considerations, while still having all the functional components to be considered as a computer. So that card itself can be considered as a computer because many things are being removed. However, the processor, memory, network, these wants to be there. Multiple processor boards, IO boards and networking boards are placed in the same chassis. So I can have one computer, one motherboard on which multiple, you can have a graphics card, different cards can also be installed on a machine. Each blade processor board boots independently and run its own operating. So I can have multiple blade servers which can be installed on your board itself, and those operating system can run independently. I just have to select that operating system. Is it understood for parallel system? Any doubt on the parallel systems? Okay. So we'll go for the another next kind of operating system is known as the distributed operating system. We'll go for distributed operating system. So in contrast to parallel operating system, in distributed operating system, what you have multiple number of computers are connected for sharing the resources and all. In parallel, what you have, one computer has multiple number of processors and they do have direct access to the common memory. Distributed system says there are multiple number of autonomous computers. They do have their own memory, they do have their own IO, everything they do have their own. We are just connecting them for sharing informations and for processing. Correct? So these are referred as loosely coupled system, whereas parallel system were called the tightly coupled system. These are called loosely coupled because they don't have common memory, they do not have common clock, they may be geographically separated, not in a machine. So distributed systems use multiple central processors to serve multiple real-time applications and multiple users. Correct? So they do have multiple number of processors to serve multiple real-time applications. So it is a collection of physically separated heterogeneous computer systems that are networked to provide user with access to various sources. So these are physically separated. The ATM network that you can see, the ATMs, so they are being physically separated, right? They are heterogeneous computer system, not necessary that all the ATMs are of same configurations. They are being connected in a network, but a special kind of distributed operating system works over there. So processors in a distributed system may vary in size and function. So processors may be different. It behaves, but in parallel processing, all the processors are of the same kind of processors. In distributed, it behaves like one system and is transparent to the user. So even if multiple computers are there, for the user, the user will think that I am working with one computer, with my computer only. The data may be present in some other computer, but I can have access to that data. User doesn't have to bother. Your account may be in somewhere else. Your account may be in Bhubaneswar, you go to Jammu or Kashmir and there you want to draw the money from a ATM, as if that machine has access, it will give you the it can allow you for transaction or give you the money, because the user doesn't know that how it is being connected and how it is being verified and from where we get the data. So it behaves like one system. It increases the computation speed, functionality, data availability, reliability. All these are being increased. Availability, reliability, speed, functions, these are being increased in a distributed system. The processors communicate with one another through various communication lines. So how do the processors communicate? Or actually processor belongs to the different computers. They communicate through high-speed telephone lines or buses or networks, right? The operating system manages the communication between processors, depends directly on networking on their functionality. So what is the basic difference between parallel and distributed systems? In parallel systems are tightly coupled systems, or they are what they share a common memory. One system has multiple number of computers, but in distributed system these are called loosely coupled system. They do have their own memory. They do not share clock, and now what you have, multiple number of autonomous computers are being connected together. So what is the advantages of distributed system? It says that with resources sharing facility, a user at one site may be able to use the resources available at another. As the resource can be shared, multiple computers are being connected through the network and resource can be shared. So a user at one site may be able to use the resources available at another site. Right? I can see that those informations, I can access its hard disk, I can access the data, right? Not even that, I can set my what parameters, and the program may be executed in some other machine. So speed of the exchange of data with another via electronic mail. So speed of how, so I submit my program to one computer. That instructions are distributed among multiple processors. It will be executed and it will give me my result. So if one site fails in a distributed system, the remaining site can potentially continue operating. Here, if some of the site fails, one of the computer operating. A better service to the customers. It gives better service to the customers. A reduction of the load on the host computer, because one computer load is not given to the computer on which the request is made, because the load is now being distributed. Reduction of delays in data processing. The in data processing, what there's less delay in the data processing. The disadvantages are not written over here. The problem, there are some disadvantages of this distributed system as well. And the problem with the distributed system is that first thing is that we have to rely on the network. We have to rely on the network because the data, all these are being communicated to the network. So it is being the speed of the processing is limited by the bandwidth of the network. Your processor may be very fast, but if your bandwidth is very low, so transferring data will take a lot of time, right? And if you have very less data to be executed, then the distributed system will be more costly for you. So sometimes the cost is feels to be more if you have very less. That suppose I have to do some few computations only, I may not go for a distributed system, right? Okay, any doubt between parallel and distributed systems if you have? Otherwise you'll go for the real-time systems. Okay, so coming to the so we'll go for okay. Okay, hello. Can you hear me or not?
Yes, sir.
Okay.
Yes, sir.
Okay. So the next kind of operating system is the real-time operating system. Here, the emphasis is given on the uh, response time. We want the work to be done at the time it is expected to be. We do not compromise on the time. When we do not compromise with the time, that kind of systems are called the real-time systems. The other factors matters later. How optimization will be done, how cost optimization will be done, that is different. The emphasis is given on what? The work to be completed exact at time. For example, the real time, for example, satellite launching. In satellite launching, at every functionality of the satellite has to be done at a particular time. You cannot say that I will save the cost for which if it will be late for 5 seconds, it will I will save some cost and I will make it late for 5 seconds. No, that is not allowed. That cannot be tolerated. The work has to be done at a particular time, right? When you have strict limit on this on the timing, then that kind of systems are called the real-time systems. A data processing system in which the time interval required to process and the response is so small that it controls the environment. The response time is very fast. So the time it is required at the exact same time it has to be processed. Generally, the output of one system is an input for the next system. The output of one system is an input for the next system. So output must be produced at exact time so that the input must be given to the next one. In satellite launching, you have seen a part of the satellite is being detached and it may be connected to some other. So exact time it has to be released, right? So at that time we may compromise on other things, but the work has to be done at a particular time, right? So a real-time operating system must have well-defined fixed time constraints, otherwise the system will fail. It has a fixed time constraint, well-defined fixed time constraint. Otherwise, the system will fail. Scientific experiments, medical imaging systems, industrial control systems, weapon systems. So there are various sensors are there which are giving the data, and we have to fire on a particular, we have identified and fire, then you have to take a decision at the runtime exact time. You have to have a very accuracy and exact time on which it has to be fired. The robots air traffic control system, in air traffic control system, you cannot compromise on anything over there. So those kind, there only we use the real-time systems. These real-time systems are hard real-time systems and soft real-time systems. There are two different kinds of hard real-time and soft real-time. What is hard real-time systems? Hard real-time system, they guarantee that critical tasks completed on time. If you have a critical task, that has to be completed on time. Secondary storage is limited or missing and the data stored in ROM. Generally, the data is stored in ROM. These are not being transferred to the secondary storage because that will take a lot of time, because you know that writing to the disk takes more time than to the memory. So data is generally stored in the ROM. Virtual memory is almost never found. We do not use virtual because everything is we want to do in the memory itself. correct? So hard real time has critical task completion time. So other we have strict bound on the time itself. The soft real time systems, a critical real time task gets priority over the other tasks and retain the priority until it completes. In soft real time system, we may consider some priority over here. We may have some priority may be given. This is also a real time system. This is also a real time system, but we do have some flexibility over here. Some flexibility by looking into the priority of the task. Suppose, for example, if I say when you have a job in your company, your entry time is 10 o'clock, and if it is 10:01 also, it will be considered as late. It is a hard real time system. Soft real time, sir, you are giving in your examination, you are writing on your copy, the bell rang at 10 o'clock, your exam over, but still the teacher is waiting for 1 minute, maybe 10 seconds or 30 seconds to see that the student is writing the roll number or something of value over there. The teacher may sometimes wait, right? So looking into the criticality of the task, sometimes by looking at the priority, although the time is fixed, some consideration may be there. So that is called the soft real time systems. So these are the different operating systems that we have discussed. Besides this, we have also online systems. Online systems are like the time the time the task is requested, at that time it has to be served. Like in ticket reservations, so the time at which the request is made, the same time it has to be served. These online systems, right? So we have discussed the various kinds of operating systems. Correct? If you have any doubt on these operating systems, different types of operating systems, you may ask me now. Otherwise, we will go for the next topic, is the operating system services. We have services of operating system. Okay. We have discussed the batch processing, we have discussed the multi-programming, time sharing, parallel system, distributed systems, real-time systems, personal computer systems. We have some of the systems I have not discussed over here. You can read of your own also. Those are handheld systems like your laptops or tabs. We have initially we can have
Sir.
also. Yes, hello.
Sir, in the time setting system, response time also need to less, and in the real time system, the response time is also need to be less. Then, which is better type of OS according to today's world, time sharing or real time?
See, first thing is that everyone has advantages and they have to be used in a particular operating. So we do not compare in terms which is better. We are saying that which operating system can be used in which place. Correct? So we are not saying that this is better and this is less better. It is not like that. Multi-programming has some advantages. Time sharing has different advantages. So every operating system has some advantages and disadvantages. We cannot use your multi-programming is having some advantages. But in real-time system, more emphasis we give to the time. But here in our computer, suppose for a personal computer, if you use the real-time system, what will happen? The cost may be increases, or better optimization cannot be done, right? So it depends on the use actually. First thing. Second is that time sharing. You have to about the time sharing operating system with the real-time operating system. They are totally two different ways it is being used. Time sharing operating system generally being used with where in our personal computers, like Linux operating system, it uses time sharing and round robin scheduling. But real-time operating system, they have their own operating system design where the strict time constant is being specified. So There the optimization part is not given that importance. Optimization part is not given that importance. But in our computers, in our operating systems where multi-programming and all these are used, emphasis is given to the optimization of resources and everything. So we are not comparing that which is better or not. We are comparing that where they can be used. Everyone has some features and they are being used in different places. Is it understood?
Yes, sir.
Um, any doubt over here? Let me first take the attendance and then I'll address the queries. Roll number 1, 2, roll number 2, 3, 4, 5, 10, 22, 25, 27, 30, 37, 39, 73, I think 74 is the last one. Okay. Let me call the roll numbers, those who are absent. Roll number 2, roll number 22, 25, 27, 30, 37, 39 and 73. Okay. Now you ask if you have any query. Now you ask. We will not start the services because today we don't have time. We'll discuss the operating system services in the next class. So now if you have any doubt, you may ask.